Hey there, it's Cooper Codes. In this video, we are going to be discussing Apollo server resolvers for beginners. I'm going to start by doing a GraphQL introduction, and then I'm going to discuss the syntax and setup of the Apollo server resolvers themselves. Let's get into it. My GraphQL overview is going to be very pseudocode-like. That means it's not saying any specific syntax, I'm just giving you the general ideas. So first, let's discuss this GraphQL overview. We have a user here, which is probably a type in our GraphQL, and it has a name, a password, a description, and something like karma, for example. So GraphQL helps us make calls to get specific information from the user. So our GraphQL query is going to look like something in the middle here. We're going to take the user type, and we're going to search for something, for example, the name of Cooper Codes. And it's going to have description, and karma is this thing we want to get out of this user object. And so this would return a JSON object that looks something like this. The description, subscribe to Cooper Codes or else, and then the karma amount. And this query is saying, hey, this user object over here, let's get the description property, which gets this string here, and let's get the karma property out of it. We can add more fields to this, for example. We could have a name field at the very bottom, and then in this returned object, we would also have the name, for example. This is a basic idea as to how GraphQL queries work. So before getting into Apollo server, it's important to understand the three GraphQL operation types. I know I'm not showing you any GraphQL off the bat, but these are just good terms to know, so when I mention them in the future, you know what I'm talking about. The first operation type is a GraphQL query, for example. This is when you want to get data from your GraphQL server. Then you have mutations, which is when you want to change data on your GraphQL server. And then subscriptions, when you want to subscribe to a data source. I'm not really going to cover subscriptions that much in this tutorial as they're more complicated. You'll generally see queries and mutations used for most of your resolvers. So, there's a couple things to cover here. What is the main difference between a query and a mutation? Well, query fields are executed in parallel, while mutation fields run in series, which means they run one after another. And so why is this important? Imagine if you have a buy item mutation is the one I like to think about. You want to make sure that you don't sell more items than you already have. And let's just say in some crazy world, your buy item takes 1 minute and it makes a check to see if the item's in stock at the top of your backend code. So if those buy item requests ran all at once, then you would sell more items than you already have. This is a great example as to why queries and mutations exist in GraphQL, is when you make a mutation, you want to make sure that they run in series. So now we can start to talk a little bit about resolvers, which is what you're here for. So our Apollo server is going to have something called type definitions. Type definitions is where the actual GraphQL comes into the Apollo server. So we can define types such as queries, mutations, regular types, all the things like that. Queries are a certain type that we can use on our GraphQL type definitions. For example, if we have this type query here, we're going to have the query number 6 and then the query number 7. So this is just saying, hey, here are some queries that exist. Our Apollo server needs to give these respective resolvers some actual code to work with. And so this is called the resolver map. What the resolver map does is you can take in the queries here and then you make them the same name, like number 6, for example. And then inside of these brackets, you have all of the code you need for that specific query. For example, in this situation, the code is very simple. We just have a return 6 and a return 7. But you could imagine you can have more complicated code inside of here. This is going to be a JavaScript file at the end of the day, and so you can use backend JavaScript here to create any code that is necessary for your project. So I'm going to jump into the documentation here just to show you guys where you can get this information yourself, and also just recognizing that if you're new to Apollo server, the documentation is super great. So you can see this const resolvers looks similar to what we had in the previous slide. Except you can see this user resolver has 4 arguments. So Apollo server provides us with these arguments that we can use when working with our Apollo server resolvers. And you can use these arguments for queries, you can use them for mutations and subscriptions. They exist for any resolver. So when looking at what these resolver arguments actually are, we can go into the documentation where they give us a decent definition. The first parameter is going to be the parent. This is important when you deal with resolver chains, which I'll explain in a little bit here. Then you have the arguments. This is the one you're probably going to be using all the time. If you put any parameters into your GraphQL arguments, then you're going to be able to access them through this argument, so the second parameter. Then you have the context. Context is helpful for if you need information across all of your resolvers. One of the main ones you're going to be seeing this context argument be used for is specifically authentication information. And as they mentioned in the documentation, and anything else to track across resolvers. This info field isn't used that much, but it's good to understand that it exists just in case you ever need to do anything that requires the execution state or, the path to field from root. I'm not going to act like I know the info in super depth, but for most of your stuff, you're going to be looking at the arguments and you're going to be looking at the context when you create your resolvers. And most importantly, think about what your resolver is going to return. For example, the main ones you're going to be seeing in your code is returning an object, for example, or an array, which would be a list of objects in most cases. I would say if you're just starting out, just worry about these two, and I will show you guys examples of what to return in which situations, especially when it comes to defining your own types. So if we were to define the type book, for example, and that book becomes a return statement in a resolver, then we would need to return an object that's similar to this syntax. I'll show you guys all of this in a second here. So let's get into creating a basic Apollo server that we can make some test queries on to show you guys the basic logic of resolvers. All right, so first things first, you're going to want to go to an empty folder and get a text editor with a terminal. So we're going to npm install apollo-server, which is the Apollo server, surprise. And then I'm also going to download nodemon so we don't have to keep on restarting our server whenever we make a change, is what nodemon helps us with. All right, so you should have a package.json and a node modules here, which is great news. Package.json is pretty simple. It's just going to have nodemon and this guy in there. So we can go in here and make a start script to actually use nodemon. So I'm going to say scripts, and I'm going to set it equal to an object. And these are all the different types of npm scripts you can create yourself. The first one I'm going to say is start, and then get a comma so you don't get that issue. And this is pretty much saying, when I say npm start, what do I want to have happen? I want to do nodemon, and then I want to have our server file. So I'm going to call this server.js. It's a file we haven't created yet, but now if we run npm start, it's going to run nodemon on server.js. So let's go create this .js file for our server. All right, so this is going to be our actual Apollo server code. And so these aren't even going to be resolvers or anything like that. This is just getting the Apollo server running on your machine locally. The first thing we're gonna have to do is get the actual Apollo server constructor out of the Apollo server package we just installed. So we can say const Apollo server is equal to require Apollo server. I'm also going to have two more require statements. One of them is going to be our type defs, which is going to equal require dot slash, and this is a folder that I haven't made yet. I'm going to say GraphQL, and then I'm going to say type defs. So these are two things that we need for our server to actually run. Is our server needs a type defs and then a resolvers, kind of like what I was discussing before, but this is the actual syntax of it. And so GraphQL and then resolvers here. So I'm just going to pretend these exist. You are going to get an issue if you try and run this code right now, but this is just the setup, and then we will make type defs and resolvers actually exist in a second here. So now for actually setting up the server, I'm going to say const server is equal to new Apollo server, and they make it really easy for us. All we have to do is say type defs as the first parameter, and then resolvers as the next parameter. Then at the bottom, we want our server to actually start running, so we're going to say server.listen port. This is the actual port your server is going to run on. I'm going to say 5000 for this video. So like I said before, type defs and resolvers don't quite exist yet. So let's go and create a GraphQL folder. And the reason why I do the structure of this is because the GraphQL and the actual server itself are different code. This isn't GraphQL code here, and so I like to divvy it up in a way that makes sense. And so inside of our GraphQL folder, we're going to have the type defs. So I'm going to say type defs.js. Then I'm also going to make a folder for our resolvers. Okay, so type defs is going to be our actual GraphQL code. And so one common thing for beginners is they're super confused as to how do you actually create GraphQL code in JavaScript, right? You have to use this const GQL, which is saying get the GraphQL language from Apollo server. And Apollo server is just one of the many ways you can provide this GQL tag. GQL exists in many other packages as well, but since we have Apollo server already here, we can just use the Apollo server GQL tag. They're all the same at the end of the day. And from this type defs, we want to say module.exports. So if we ever require this file, for example, we want to get this out of it, GQL, and then do backticks. And now anything inside of the backticks is going to be GraphQL code. Here's where you can actually put your GraphQL types. Anything GraphQL related is going to be in here. For this tutorial, I'm going to make a very simple thing. So I'm going to make a little comment down here discussing what we're going to create. We're going to create a message. And so the message is going to be a GraphQL type, and it's going to have one text property. That's it. So you're just going to have a message and you're going to be able to see its text. Then I'm going to make a query that allows us to pass in the string we want the text to be. So you can imagine if we do the query like make message, we're not really making a message here because we have no database. That's why I'm making it a query. But if we say make message and then we say text is equal to hello world, we're going to be expecting a message type back specifically of an object that looks like this: text hello world. And so we want that input text to be set to the actual message block we end up creating. So this is a good example of showing you guys the full process of creating a resolver, for example. And this is very simple. If you're interested in more complicated things, make sure to jump to the other videos on my channel. So let's start by creating this message. We can say type message, this is all GraphQL code, by the way. And I'm going to say text is equal to a string type. And this is going to be the entire block, is just this simple message and text. And so now down here, we can say type query. So these are all of our queries. And I'm going to say make message is going to take in a parameter of message text, just to change it from regular text above, and that's going to be a string. And we are expecting our return type to be of the message type. So here you have the type message. It's a simple data block defined with a text, and it's going to be a string. And so with this make message, we can get this message text and create a message block using this inputted text here. So for resolvers, I'm going to show you guys the code for if you were to manage multiple different resolvers. Right now, we only have resolvers that are specific to messages, for example, the make message query. And so in here, I'm going to make an index.js. And I'm also going to make a messages.js. Index.js in this file is what's going to pretty much take all of your resolvers. So you could have messages, you could have profiles.js, you could have users.js. If you have a bunch of different resolvers, for example, right, you want them to be organized in their own files. So all the messages resolvers go in messages, all the books resolvers go in books.js, whatever your application is. And index.js is going to pretty much take all these different resolvers, put them in one little package, and then in our server.js, when it says, hey, grab the resolvers folder, because right now you'll see this is pointing to a folder. What happens when you say require is it's going to look at the index.js of this folder and see if it's exporting anything. And so that's how we're going to put all of our resolvers into one file. So if we want to grab the resolvers from messages, for example, you can say const messages resolvers is equal to require, and we're going to go to / messages here. This is pretty much saying, hey, go to the messages.js here and get whatever it's giving us, whatever it's exporting to us, which is going to be our actual messages resolvers. I'll show you guys in a second. But the index.js itself is going to be exporting a block that's going to have the query types, and is also going to have the mutation types. You'll see this is looking similar to that kind of simple code I showed in the beginning of the video, but this is kind of what it would actually look like in production or an actual application. And so we're going to use the spread operator, and don't get too scared. This is just saying, hey, for all of the messages resolvers, we want to take the queries from this messages resolvers, and we want to put them in this query. So if there are like 5 queries in your messages resolvers, it's going to spread them out in a list and pretty much say, hey, put them all side by side. That's what this ... is doing, is it's just using the spread operator on these queries, so it gets all of your query resolvers out of messages resolvers. And the exact same thing is going to happen for mutations. Here's the thing, is we don't actually have any mutations right now. And like I said before, mutations and queries are the exact same in their actual backend code, besides how they're processed, like I discussed in the beginning of the video. So if you end up making mutations, it would look like this when you export here. But in this video, I'm not doing mutations, so I'm going to comment this out like this. I'm just leaving this in the video, so if you go and do mutations and you're confused as to what you should do in your index.js here, your mutations should look like just like how I had it. All right, so now we can go to messages.js and actually create some real Apollo server backend code. So messages.js is just going to be a module.export statement. And if you're confused as to why I'm using module.export so much, is because when you try and require a file in JavaScript, for example, require./messages, what it's literally doing is it's grabbing whatever you set module.exports equal to. So right now we're setting it equal to a data block right here, or an object. An empty object for now, right? And so if I were to require this thing over here, it's actually just saying this. It's equal to an empty object, at least for now. But the goal is to actually have that empty object show us actual resolver code at the end of the day. And so in this module.exports, we are going to have our query here. And as you guys will see, this pattern of query right here is constantly repeated throughout all of your different resolvers. This is kind of the basic setup of what Apollo server wants, is queries and mutations, and then of course their definition. So in here, we can define those actual functions. And so if we go over to our type defs, our our query here is called make message. So we have to go over here, grab the make message. And remember, there's those 4 parameters, and the first one was parent. We don't need parent, and so you can use an underscore to ignore the first parameter. That is super important in Apollo server to understand, because you'll see a lot of underscores throughout Apollo server code. It's because they're ignoring parameters. That's just super important to understand. Then we have the arguments here. And for now, I'm just going to have args like this so I can console.log and show you guys what the actual arguments object looks like. And so just like a normal function, we can go in here and we can do whatever JavaScript code we want. So for example, I want to console.log args. This is a great one because it's actually going to give me that, arg. I'm just going to return an object, and it's going to have a text of this is the text I want. And this is all I'm going to return right now. And I'm returning it like this because this block of data needs to resemble the actual message type here. That's important to understand, is if you say return a message, it's going to be expecting something that looks like the actual message block, or the block of data that message represents. So let's npm start our actual application. So I jumped over to the server.js. If you get to line 11, that means it created your server successfully. And so I just a little console.log saying listening on port 5000. And so we can go over to localhost 5000. I'll actually say that on localhost 5000. And so we can go over to localhost 5000. All right, so on localhost 5000, you're going to want to press this query your server button. And so this is what your blank slate's going to look like for when you use the Apollo Server Explorer. What Apollo Server Explorer does is it gives you an easy to use interface to make actual GraphQL queries and run resolvers on your server locally. So for example, if we go to the root, we'll see our only root types we have are query. So we can say, okay, add the query, and I want to make this query a make message query. And so you can press this little add button and it's going to make the code for you, which is pretty neat. And no, this isn't cheating because it's the exact same code you would write yourself. And so you can see it's building up this query called query, and it's going to use the make message query here. And now it needs the actual arguments. So you say, hey, give it the argument here. And then when we get the actual field as a result, we want to see the text of the message that we've created. So if we press this little run query button right here, you'll see it saying this is the text I want, and it's giving us a 200, which means our resolver is actually working. So if we jump back over to our Visual Studio, in our Visual Studio, we're going to see a couple of things. This text is coming from here. It's saying this is the text I want. The actual arguments are showing up in my console here. It's saying, hey, that message text is null because we pass in nothing. And so this is what our arguments are looking like. And so to get the actual message text value, we can say console .log args, and since it's an object, we can say .message text. And so take a look at this. And so you can see when we're running our query, we're getting this hard set text of this is the text I want, right? And so the resolver is resolving data, and it is a message type. We can change this text to whatever we want, like subscribe to Cooper codes. If you got this far in the video, you probably should. And so we can change this text. And then if we go back to our sandbox, we can run the query again, and it's going to change to whatever text we have here. And so this is a good example of actually hard setting that text to a certain value we have in our backend. But in our variables here, we can pass in the variable we want message text to be equal to. And don't overcomplicate this, guys. This message text here is just like a parameter in the function. It's just GraphQL looks a little bit strange, but pretty much you have the variables here. And so for the variable message text, which means $ message text, that's like $, means it's coming from the variables. If we go in here, we can then say, this is Cooper codes with the custom message. And I'm going to set this variable. And if I run my query again, it's still saying subscribe to Cooper codes. This is because in our backend code, what's happening is we're setting this text to subscribe to Cooper codes. But hey, check this out. You see these console.logs here? We can see that this message text is now being set to the actual string, saying this is Cooper codes with a custom message. And so what we can do is instead of setting this text equal to the string here, we can then say args.message text. Okay, and so if we run back over here to our actual Apollo server, we can run the query now, and it's going to say this is Cooper codes with the custom message. And I'm just going to say hello world. I'm just going to add a bunch of numbers at the end, and you'll see now we're actually using the query to make custom messages kind of come back to us. I know this seems super simple. You guys are over here like, okay, whatever. But if you can understand how to make Apollo server resolvers here, you're completely set, because my main idea of this video is I'm showing you guys the most basic way to use Apollo server ever, okay? This is a very basic message. This is a very basic thing, but you've actually covered a lot of ground here, and you'll see Apollo Server is interesting because you're not actually limited by your skill in Apollo Server itself. You become more limited in your skill of actually writing JavaScript code. In between these brackets of any resolver you want, you're going to have JavaScript code. Whether that code is interacting with a database, whether that code is, waiting for a promise to be fulfilled, those are all JavaScript oriented things that I do cover in depth in other videos working with Apollo Server resolvers. And so this video was just showing a basic idea of how to set up a resolver. Pretty much if you understand how this make message works, you can really do a lot of different other things throughout your entire Apollo server. A point I will make before ending this video is that mutations are exactly the same as queries when it comes to doing their whole syntax. So you're gonna have mutation and you're gonna have this is a mutation. And you can do it's going to be the exact same syntax. As I mentioned before, it's going to have the exact same parameters with the parent and the args and the thing like that. And so hopefully this video was helpful in getting you guys up to speed with Apollo server. And hopefully it was also helpful in showing you how approachable Apollo server can be. Obviously there are complicated JavaScript things you have to learn if you want to build an authentication system, if you want to work with databases. But this video is just giving you a basic idea as to how the resolvers themselves work. So thanks so much for watching. And if you're interested in GraphQL and Apollo server content, I have a couple other videos on my channel I would recommend checking out, and I will link them in the description. Thanks for watching.